So our next presentation is going to be JBoehman, and this is going to be focused on radar.
Hello, my name is JBoehman, and for my senior project, I really wanted to focus on the behind-the-scenes work that goes on inside military defense. This field has always interested me. However, I never really truly understood the science that's filtered into it and how it operates. So after a little bit of background research, I determined that I wanted to become more knowledgeable in radar and to pursue the challenge of actually understanding the math, the physics, and just the overall principle behind it. To get an expert's perspective on the basics and applications of radar, I contacted Bill Saunders, an electrical engineer at SRC, which is a defense contractor for the military. I interned with Mr. Saunders for approximately 2.5 hours on Mondays, Wednesdays, and Fridays for 2 weeks, for a total of about 16 hours. While at the Charlottesville office of SRC, Mr. Saunders and I talked for a while just about the basics of radar and how it functions. At first, this was difficult for me because I found that I'm a visual learner, and to try to understand something that you can't see with the naked eye really wasn't the greatest combination. So Mr. Saunders referred me to an MIT radar course, which they actually show their employees that have just joined the company. And this radar course went over the history and just the basics on how radar works. So for radar, the history is an important part of beginning to understand how the evolution, the technological advances, the function, and the overall importance of radar. So a couple of names that you'll tend to hear when regarding the history and the implementation of radar are James Clerk Maxwell, who demonstrated that electric and magnetic fields travel in the form of waves, and that these waves travel at the speed of light. Another name that you'll tend to hear and you might know about is Heinrich Rudolf Hertz, whose last name is the base unit for frequency. What Hertz did is that he basically discovered these electromagnetic waves in space, thus proving Maxwell's theory correct. And lastly, you also hear of Robert Watson Watt, who suggested that radio wave technology can be used to detect objects out in space. This suggestion led to the creation of the chain home radar system, which was the world's first implementation of radar in regards to the military. The chain home radar system was built along the coastline of England during World War II, and more specifically the Battle of Britain, which is where the German planes would come in and bomb cities such as London. What the chain home radar system did is that it gave the British an advantage of an early warning system so that they could get their aircraft in the air before they even saw German planes with their actual eyes. England eventually went on to be victorious, and thus proving the importance of radar in the military. So radar has a basic, simple, overall concept, but a steep learning curve. So radar's basic function is to detect moving targets. And this is possible due to the fact that electromagnetic waves are reflected whenever they hit an object out in space. And if these reflected waves come back to the source of pulsation of electromagnetic energy, then it can be determined and concluded that there is in fact an object in space. The distance between the object and the source of pulsation of energy relies on that constant speed, which is the speed of light, which is 300,000 kilometers per second. So through the use of mathematics, the distance between the radar system and an object can then be calculated. So after getting all the basics out of the way with Mr. Saunders, he introduced me to something called reverse engineering. And what reverse engineering is basically taking a product and breaking it down to its specifications. So take this PPRU-1M Russian mobile air system, for example. If you get a straight shot of the antenna, you can hold a ruler up to the computer screen, measure its height and width, and from there you can take its proportions and compare it to other radar systems. So by doing this, you can really determine its range that it operates in. After truly seeing the importance of radar in the military, I really wanted to explore how its future applications and evolution can really potentially save lives in the military. As of 2015, there have been 50,000 casualties between American and coalition lives. So you can imagine that how many friends and family of these heroes that have been affected. So that really this number really drove me to want to explore the how the future applications of radar can have a positive impact on this number. And I narrowed it down to the two best future applications that I thought could be a positive influence. The common theme between these two future applications is to see without being seen. So the first application that really intrigued me is something called passive radar. And what makes passive radar special is that it can't be tracked by the enemy. And this is possible due to the fact that passive radar uses very high frequency digital radio and television frequencies as its source of energy instead of actually pulsing out its own electromagnetic energy. Passive radar also has the ability to track low-flying targets, which currently isn't possible today. This is because the military uses something called active radar now, which has a lower detection rate, so it can't track low-flying targets. Passive radar is overall more capable, more adaptive, and more efficient than its brother system, active radar. However, together, these two systems can really provide good reconnaissance of a certain area. And companies such as Raytheon are currently in the developmental stage of passive radar and are on the fringe of actual implementation. So the other application that really intrigued me is something called through-wall imaging. This system operates in the S-band of the electromagnetic spectrum. It's a continuous wave radar, it's frequency modulated, and it has a spatial frequency range gate that is connected to a multi-input, multi-output antenna array. And the spatial frequency range gate's responsibility for the system is to remove the wall from the image, while the multi-input, multi-output antenna provides the least complicated solution for the whole process. Together, these characteristics allow the system to quickly take in, analyze, and produce a radar image at 10.8 hertz. So simply put, this through-wall imaging system can detect moving targets through walls in a building. So this system can be placed outside of the building and provide reconnaissance for the area before any soldiers on the ground have to. So these two systems together, through-wall imaging and passive radar, have a great potential to save lives in the military. For my community service, I landed a great opportunity with our local Green County Library. I contacted Miss Michelle Eric about teaching a type of radar class, and after getting approval from the Teen Advisory Board, I was able to teach this class. This class consisted of 9 kids, and I taught these 9 kids about the basics and the history and the background of radar. But after getting all the boring stuff out of the way, I split them up into 2 groups, and I gave them instructions on how to build a crystal radio. And this crystal radio is made out of materials that can be found around the typical household, except for the germanium diode and the 2000 ohms earpiece, which is extremely sensitive. As you can see, there's a 25 and a 90 turn coil. This was the most difficult part of the whole project, where these kids literally had to wrap wire around the toilet paper roll 25 and 90 times. So you can only imagine how frustrating it would be if you lost count halfway through the 90 turn coil. Here you can see that after getting all the materials together and getting the coil worked out, I connected each of their coils to the main foundation, which I built beforehand. We actually did pick up some static, but we did not, unfortunately, pick up any voices. And I believe that this is due to the fact of our location of being in a building, and we only had about a 15-foot antenna. Here's another picture that you can see how my right hand is tuning the radio with a tuning bar, which was just an extended paper clip, and adjusting the volume with the capacitor, which was 2 paper towel rolls just stacked on top of each other, and you would just move it side to side. As for my legacy, I wanted to really get radar out as a type of something exciting that isn't really taught in the school curriculum. So I printed out how to make a personal radio instructions, and I gave them to our physics teacher, Ms. Leah Flansburg, and I gave them the opportunity to create a personal radio whenever teaching about radio wave technology and the electromagnetic spectrum. So as for my advice for rising Burdick seniors, I know it's cliche, but do not procrastinate. Anyone that knows me knows that I'm a terrible procrastinator. So, but I took my time with the important parts of the project, such as the thesis paper, and it really turned out great. I don't regret it at all. Next year, I'll be attending the University of South Australia in February 2017, which is their fall semester. And while there, I plan to expand my knowledge on engineering and radar specific. Thank you. Are there any questions?
South Australia?
Yeah.
How did you pick that?
My dad's job is moving over there, so I thought it was a great opportunity for me to go study abroad. So
I think that's great. Yeah. My son just came back there a couple of weeks.
Oh, really?
He loved it. Yeah.
Awesome.
So, yeah.
You had a slide that said 50,000 casualties. What was that?
There have been, as of 2015, there have been 50,000 casualties between American and coalition partners in Iraq and Afghanistan.
Okay.
Yes.
What is crystal radio? I have no idea what the purpose or what that was built for. What is a crystal radio? What were you trying to get?
Well, it's just a basic way to teach how radio waves work and the simplicity that radio wave technology can provide. Yes.
In terms of for using radar in the military, I know that militaries around the world are pushing aircraft and other vehicles that have radar collecting materials kind of basically visible for radar. Do you think that our radar capabilities will be able to evolve and keep up with that technology?
Oh yeah, definitely. I think radar is one of the most can provide the most reconnaissance and defense for the military in terms of just technology wise.
With respect to the through the wall radar, did you say 10.8 hertz? You might want to expand on why you would use some frequency that low.
Well, it's more like it's just so sitting through the wall of having lower frequency provides better radar image.
Did you learn anything about underwater radar? Did it come along about the same time?
I did not research anything about that.
Any questions? Okay, thank you, Jeff.